Welcome students. During previous class, we have discussed a topic that was equipotential surface. So we have discussed in detail what equipotential surface is and how we will calculate the work done between the 2 points which are at the same potential surface having same potential. And finally, we have concluded and we have discussed different points which were linked with that type of the surface. Now today we are going to discuss another important topic, that is equipotential surfaces. After equal potential surfaces, this is the most important topic, that is electric field has a negative of potential gradient. What it means that it is the negative of potential gradient. First of all, we have discussed how to calculate work done when we are moving any test charge particle inside a field, electric field, against the electric field. So at that time, we have seen that the del R and F both are along the E or F, both are along the same direction. We have to do some work against electric field. Against the field, we are moving any charged particle, and to overcome such repulsive forces. There was a test charge positive charge particle. We were bringing this charge particle to another charge particle vicinity where it was producing electric lines which are already moving outward, and we were trying to move the charge particle towards the test charge particle Q naught towards the charge. So here it was. We have done work done, and I have already discussed why we have done unit positive charge Q naught, which we have moved against electric field, and it was calculated by using this formula, that is the W is equal to minus F del R. This minus sign came due to the angle as well, that is 180, and 180 is minus 1, so that's why it is F. So to calculate the force in case of electric field, when you're moving this charge particle inside electric field E, then at that time force acting on the charge particle Q naught will be this one. So there is no confusion to apply this condition of the definition, the concept of the force. Whenever you are moving any charge particle Q in the field of a charge, that field intensity or field distance E, then this force will be acting on this charge particle. So if you put this one in this equation, then you will be getting, that is E, this means force, into displacement, that is the del R. So if you simplify it, so W divided by Q, you have deliberately done it so that during the previous class you have already done amount of work done per unit charge, that is basically electric potential. So here it is, electric potential. You got electric potential from this equation. So the other side is same as it was. If you look at, you interchange, you divide the electric potential with the this displacement, you are basically getting electric field. So the negative sign del V over R, del R is the rate of change of potential with respect to displacement, and this is called basically potential gradient. This one is called potential gradient, rate of change of potential with respect to displacement. Why? If you look at what is the concept, what are the meanings? Meanings are very much simple, that if you are having any charge that is Q and there is a field produced by this charge particle, direction of this field is outward direction. So if you look at, this is the direction of the charge particle and electric lines of forces are along this direction. You are trying to move any charge particle Q naught, that is test charge particle Q naught. You have moved this charge particle towards this direction. We have already discussed in detail. So look at what's the angle between the two. E, this one is E, electric field. This one was E, and the upper one is the direction of the charge of the displacement. Both are along opposite direction, so the angle will be 180, and cos 180 is basically -1. So that's why you are getting this one. So this is the concept. When you are moving away from the charge particle, of course you see the electric field strength is decreasing. So here it is del V over R. This is the rate of change of potential with respect to displacement when it is called. This one is called potential gradient, and formula to write the potential gradient is del V over del R. Negative sign shows that the field strength decreases whenever you are moving outside, away from the charged particle. So here it is, from where you have started, you are calculating work done, and you have calculated work done by using this formula. And if you look at, here is the force, and how the force is calculated whenever a charged particle Q is moved inside the field. The force acting on this charged particle is calculated by E is equal to F divided by Q naught, and F is equal to E Q naught. So this is E Q naught. This is used by using electric field intensity. We have calculated the force, concept of the force. Due to this electric field intensity, force is acting on this charged particle. So to calculate the work done per unit charge, that is basically electric potential. So here is the electric potential. Then you have interchanged these two to get LV over R, rate of change of potential with respect to displacement, that is electric potential gradient, and you have calculated the value of potential gradient, formula of potential gradient. If you look at, again, few steps are repeated, so you come to know, we have already done. This del V over V, the negative sign indicates that the direction of field is opposite. So this is very simple to understand, opposite to the direction in which the potential difference is increasing. Potential difference is increasing means more amount of energy will be required to move the charged particle when you are moving towards the charge, and when you are moving away from the charged particle, it is decreasing. So this is the reason the opposite negative sign indicates that the direction of field is opposite to direction in which the electric potential is increasing. Both are along the opposite directions to each other. So this is the work done in moving a unit positive charge. What is electron volt? So these are some of the smaller definitions to remember, to memorize, to understand. The amount of work done moving a unit positive charge Q naught against electric field, and that is given by this formula we have already done. And then force is calculated by using this formula, and work done is calculated by this formula after putting the value of force in this formula. Here it is force, and you will get the value of the force, and then you will be able to calculate. So here it is del V, del E, del R, that is equal to del V, and you have already calculated this one. This shows that this is the amount of work done, that is Q naught V. This work done appears in the form of electric potential energy. If you look at from where you got this charged particle moved in the potential, electric potential difference del V, through the del V, this amount of work will be done. So whenever you are moving against electric field, you have to do some work, and that type of amount of work done is in the form of electric potential energy. Like if you give you an example, if you are having a spring and you're pressing this spring against the spot or against the wall, till the time you have pressed, anyone asks you what type of the energy you have stored by pressing the spring. This is the same concept when you are bringing a unit positive charge in the area closer to another positive charge. You will face some repulsive force. To overcome such types of the repulsive force, you have to do some work on electric field. So that type of amount of work done appears in the form of electric potential energy. As in case of spring, it appears to be elastic potential energy. So this is the formula to calculate electric potential energy. In numerical, wherever you are asked, you will put the value of the work done. Basically, this amount of work done is equal to the electric potential stored in the case of the charge. So here it is. Unit of electric potential energy. So unit of electric potential energy in SI unit is electron volt. An electron volt is defined as the energy acquired or lost by an electron when it is displaced across 2 points, which are potential difference of 1 volt. So this is the simplest concept. Whenever amount of energy acquired or lost by a charged particle when it is moved through potential difference 1 volt. So if there is no, then work done will be 0. If 1 volt, then we are explaining it. This was the formula Q naught del V. electric potential energy formula. So the charge of one charge particle is 1.6 into 10 raised to power minus 19. This is the charge on the positive. Del V value is 1. If you put the values and write on the units along with, and that is coulomb, we cancel with this coulomb, and the remaining ones are the joules. So this is the amount of work done, 1.6 into 10 raised to power minus 19, which is also equal to 1 electron volt. If anyone asks you what is the relation of 1 electron volt with the joule, so this will be the joule. And in case of numericals, if you are asked, you will put the value of 1 electron volt equal to this one, then you will finally calculate. So node electron volt, 1 electron volt, this one electron volt is the amount of energy acquired or lost by electron when it displaces across 2 points which have potential difference of 1 volt. What is the explanation? Basically, since work is done to change kinetic energy from energy theorem, work energy theorem. So according to definition, this is the amount of work done, and one electron is one charge of this one, and kinetic energy is 1 electron volt. 1 electron volt is equal to 1.602 into 10 raised to power minus 19 coulomb multiplied with the charge. The electron volt is just another unit of energy like joule, and this is the smaller unit of energy. Electron volt, 1 MeV, million electron volt, is equal to 10 raised to power 6 electron volt, and 1 giga electron volt is equal to 10 raised to power minus 9 electron volt. So this is the concept of electron volt, and hope you people have understood today's topic. I thank you all for your patience, and do it revise once more time. It will be more. Let's see the main points of this topic. That was negative potential gradient. From where you have started to calculate the work done, what type of the force to calculate, how the force is calculated when you're moving this charge particle Q naught in the field. This is the formula used to calculate force. Then you're calculating work, and by using the definition of work done per unit charge, you are defining basically electric potential. And after defining electric potential, you came to know what will be the potential gradient. It is the rate of change of electric potential with respect to displacement. That is del R. So this one, then you are calculating the gradient, and finally you have calculated the potential gradient, and it is equal to minus del V over R. So then you have defined the electron volt. Basically, it is the amount of work done. You have placed the values again. You have written the quantities. You have written the units, and finally you got 1 electron volt is equal to 1.6 into 10 raised to the power minus 19 joule. So again, you have repeated to get the subunits. That is million electron volt is this one. Giga electrons are this one. So these are the subunits, and this is the smaller electron volt is basically smaller unit of energy, and it's like joule. I thank you very much for your patience. Hope you people have understood today's topic. Thank you all.